Welcome to our answer key for the cumulative practice for chapter 2. So number 1 says which number is equivalent to the expression below. So we need to simplify this using PEMDAS. So remember it's P for parentheses, E for exponents, M and D are in the same step from left to right for multiplication and division. And then we have addition and subtraction from left to right for the last step. So no parentheses in this one. We do have exponents. 3 to the power of 2 is 9. So we have 6 times 8 minus 2 times 9. So now we do the multiplication and division from left to right. 6 times 8 is 48, minus 2 times 9 is 18. So our final step is just to do 48 minus 18. 8 minus 8 is 0. 4 minus 1 is 3. So our answer is 30. Number 2 says find the greatest common factor of 48 and 120. So I'm going to list off factor pairs of 48 and then see if they work for 120. So first we have 1 and 48, then we have 2 and 24, and then we have 3 and, let's see, how many times does 3 go into 48? Goes in once, subtract 3, bring down my 8, goes into 18 6 times, so 3 times 16. Then we have 4 times 12, 5 doesn't work, and then we have 6 times 8, 9 doesn't work, and then 7 doesn't work, and then 8 is already listed. So we're going to check and see if these numbers go into 120. So for 48 to go into 120, it would need to be a multiple of 5 or 10. So we could try 48 because we know 48 times 10 is going to be 480. So we could try 48 times 5. We get 40. 20 plus 4 is 24, so that's way too much. So 48 doesn't work. 24, again, for it to go into 120, it would need to be multiplied by 5 or 10. 10 would give us 240, so let's try 24 times 5. 4 times 5 is 20. 5 times 2 is 10, plus 2 is 12. Look at that. So 24 is the greatest common factor of 48 and 120. Number 3, which number is equivalent to 5.139 minus 2.64? So since we are subtracting these decimals, we line them up. So 5.139 minus 2.64, and in the blank spot, we put a 0. 9 minus 0 is 9. Can't do 3 minus 4, so we borrow from the 1. My 3 becomes 13. 13 minus 4 is 9. We cannot do 0 minus 6. Borrow from the 5, it becomes a 4, and my 0 becomes 10. 10 minus 4 is 10 minus 6 is 4. Bring the decimal straight down. 4 minus 2 is 2. All right, so that is this one. All right, next one. Which number is equivalent to 4/9 divided by 5/7? So since we're dividing fractions, we're going to do keep, change, flip. Keep the first fraction the same, change division to multiplication, and flip the last fraction upside down. Now, since we're multiplying, we just check and see if there's any cross-canceling that can happen. 7 and 9 do not cross-cancel in any way. 4 and 5 do not cross-cancel in any way. So we're just going to multiply across. 4 times 7 is 28, and 9 times 5 is 45. So 28 over 45 is our answer. Number 5, you buy orange and black streamers for a party. The orange streamers are 9 feet long and the black streamers are 12 feet long. What are the least numbers of streamers you could buy in order for the total length of the orange streamers to be the same as the total length for the black streamers? So this word right here gives us a hint on what we're going to do. We are going to find the least common multiple. So we have 9 and 12. Let's see, where do I have room? I'll try it right here. 9 and 12. I'm going to list off the first 5 or so of each multiple. So we have 9, 18, 27, 36, and 45. For 12s, I have 12, 24, 36. Look at that. So that's the least common multiple, but that's actually not asked. We're not being asked what is the least common multiple. We're just saying that after 36 feet, both of the streamers will end up being at the same length. So there won't be any extra of either streamer. So it's wondering how many streamers would I need for me to get to 36 feet? So for the streamers that are 9 feet long, we need 4. For the streamers that are 12 feet long, we would need 3. So 9 was the orange streamers, 12 was the black streamers. So 4 orange streamers and 3 black streamers. Which number is a prime factor of 572? So a prime factor means a prime number that goes into 572. Immediately, we can eliminate these two because they are not prime numbers. So now we're going to see if 7 goes into 572 or if 13 goes in. So we'll do 572 divided by 7. 7 does not go into 5. 7 goes into 56 8 times. We subtract, we get 1, bring down the 2. 7 does not go into 12. So 7 will not work, which means that 13 is our answer, but just in case, let's try it. 572 divided by 13. 13 doesn't go into 5. It goes into 57. Let's see. 13 plus 13 is 26, plus another 13 is 39, plus another 13, 12, 52. So 1, 2, 3, 4. We get 52. Subtract, we get 5. Bring the 2 down, and we know that it goes into 52 exactly 4 times. So 13 is a prime factor. All right, which number is equivalent to 7,059 divided by 302? Set it up. 7,059 in the box, 301 outside. 301 doesn't go into 7. It doesn't go into 70. It does go into 705, probably 2 times. So let's try that. Add those together. We get 602. We can't add any more to that, or otherwise we would go over. So subtract 602, get 3, 0, 1, bring down the 9. All right, so now we have to figure out how many times 301 goes into 1,039. So we're going to keep adding 301s. 3, 0, 9. If we did another one, it would be too much. So it went in 3 times, and that was 903. Subtract 9 minus 3 is 6. 3 minus 0 is 3. 10 minus 9 is 1. So our remainder is 136. But we don't write R 136. The way we write a remainder in 6th grade math is we write 136 over the number we were dividing by, so 301. So that answer is H. All right. A square wall tile has side lengths of 4 inches. You use 360 of the tiles. What is the area of the wall covered by the tiles? So for this one, we are going to figure out the area of each of the wall tiles. So each one is 4 by 4, which is 16 square inches. So you might be tempted to say, oh, it's A. But we use 360 of these tiles. So we have to do 360 times the area of just one of them to figure out the total area. 6 times 0 is 0. 6 times 6 is 36. Carry my 3. 6 times 3 is 18. Plus 3 is 21. Cross this guy out. Cross this guy out. Placeholder 0. 1 times 0 is 0. 1 times 6 is 6. And 1 times 3 is 3. Add them up. 0, 6, 7, 5. So our answer would be 5,760. Which expression is equivalent to a perfect square? Okay, so just a reminder of what perfect squares are. They are numbers that 2 numbers can multiply perfectly into. So, for instance, 1 is 1 times 1. Then we have 2 times 2, which is 4. So 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. So we're looking for a number that's going to be on that list somewhere. So we'll check each one to see which one is going to give us a perfect square. So for this one, we do the exponents first. So we have 3 plus 4 times 7. Then we do the multiplication. 4 times 7 is 28. So we have 3 plus 28, which gives us 31. So let's see if that's a perfect square. We need to keep our list going. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So 31 is not a perfect square because we went from 25 to 36. So not F. G. Okay, so we're going to do the exponents first. 3 squared is 9. So we have 34 plus 18 divided by 9. Then we do 18 divided by 9, which is 2. So 34 plus 2, and that gives us 36. And 36 is a perfect square, so our answer is G. All right, 10 says, what is the missing denominator in the expression below? So again, for this one, we're going to do keep, change, flip. So we keep our first fraction the same, flip or change our sign to multiplication, and then flip our fraction upside down. So we get a box over 2, and that should equal 3/4. So we're trying to figure out what number could we put in here to get this. Well, I know that 4 and 2 can cross cancel to be 2 and 1. And it looks like 2 and 8 can actually cancel to be 1 and 4. So now I have 1 times 4 gives us 4. So what number would I put in here? 1 times 3 gives us 3. Another way you could do this, because it's multiple choice, you could just test each one to see if you get the correct answer. That would be perfectly valid. But if you didn't have multiple choice, then you would be out of luck on that one. All right, number 11. What is 4.56 times 0.7? Okay, so we're going to, since we're multiplying, we do not need to line up the decimals for this one. We are just going to say 4.56 times 0.7 and pretend like the decimals don't exist. Okay, 7 times 6 is 42. Carry my 4. 7 times 5 is 35, plus 4 is 39. Carry my 3. 4 times 7 is 28, plus 3 is 31. All right, and then 0 times anything is going to give us 0. So we're all done with the math part. Now we need to place the decimal. So this decimal was moved in 2 places. This one was moved in 1 place for a total of 3. So from the right-hand side, we go 1, 2, 3, and place our decimal. So our answer would be, let's see, how are we going to do this? 3.192. Number 12, the area of a large rectangle is how many times the area of the small rectangle? So for this one, we have to figure out what the area of each one is. So the area of the large rectangle is going to be 7.25 times 3.07. Five times 7 is 35. Carry my 3. 7 times 2 is 14. Plus 3 is 17. 7 times 7 is 49. Plus 1 is 50. Placeholder 0. Cross these guys out. 0 times anything is 0. So this is just going to be a bunch of zeros. Cross that out. Put 2 placeholders. 3 times 5 is 15. Carry my 1. 3 times 2 is 6. Plus 1 is 7. And 3 times 7 is 21. Add these up. We get 5, 7, 5, 12, 2, and 2. Then we place our decimal. 1, 2 places in, 1, 2 places in, for a total of 4, which is going to go right here. Okay, so that is the area of the large rectangle. Okay, the area of the smaller rectangle is going to be 4 times 1.25. So over here, I'm going to say 1.25 times 4. You don't line up the decimals when we multiply. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 1 is 4, plus 1 is 4. And then our decimal goes right here. So we're saying 4 times, that can't be right. What happened? Oh, 5. 5.0. So the area of this one is 5. Basically, we're asking what number do we multiply 5 by to get 22.2575? So we know it's, 5, just estimating, we know it's probably going to be one of these top ones. We know that 5 times 5 would give us 25, which is too much. So it's not going to be that one, it's not going to be that one, and it's not going to be that one. So our answer is F. All right, I am running out of time to finish this video, so I will help you with these last couple problems when I get back. And so you don't need to submit it just yet. We can go over the last 2 when I return. If you do have any questions about the other ones, let me know. And otherwise, I hope you have a great day. Bye.